to, so you'll be able to look at this online. Today we're going to do a quick exam review. Okay, on systems of equations, and more specifically systems of linear equations. Now, we looked at this a little bit last week. I can't remember what day it was, maybe Thursday in class we talked a little bit about this, or maybe it was Wednesday. It was Wednesday because we had the whole class period and no homework. So, systems of linear equations. Okay, let's talk a little bit about what we mean. What is a linear equation? Why is it called a linear equation?
It has two points that make a line.
Because the graph of the relationship forms a line. All right, what are the forms of a linear equation?
Horizontal and vertical.
Well, those are special cases. Standard form, what's standard form?
AX plus BX equals
Standard form is AX plus BY equals C. And there were quite a few conditions on these parameters, A, B, and C, right? Does anybody remember what the conditions were? What the A has to be positive, and A, B, and C have to be relatively prime. What kind of numbers? Integers. They can't be decimals or fractions. Okay? A, B, and C have to be relatively prime integers. Right? So linear equations, So they're called linear equations because the graph of the relationship between x and y, the points that make this equation true, form a line. So that's why it's called a linear equation. What's another form of a linear equation? Point-slope form. What do we primarily use the point-slope form for? To write the equation of a line. That's the other topic that we'll look at on Thursday. We'll remind ourselves writing linear equations given a point and slope, given 2 points, so on and so forth. The point-slope form is y minus y1 equals m times x minus x1. And you can use any of these forms to write the equation of a line, but the point-slope form is the friendliest one to move from form to form. Okay, what about the final one? What's the final one? Slope-intercept, and this was on test 10 that we just took not too long back, and you guys got it mostly. Y equals mx plus b. The slope-intercept form is very useful for graphing because we can immediately see the slope and we can immediately see the y-intercept, so we can use the slope and the y-intercept to sketch a graph of a line. Okay, so that's what a linear equation is. A system of linear equations is two or more linear equations, right? Two or more linear equations. Now, what is the solution of a system of linear equations? Not 2 points. Yeah. A system of linear equations has a solution that is a point, right? The solution is a point. Or points where the line intersects. Point or the points where the lines intersect is the solution. Intersect is the solution to a system of equations, right? Two lines cross. Now, how does it have more than one point of intersection? If it's the same line, right? If it has more than one, then it has an infinite number of points. Those lines are straight and they can't curve and touch each other just twice. So if a line has 2 points in common with another line, that means it's the same line, right? We're not going to go back into, I'm not going to test you on the consistent and independent, and inconsistent. Okay, what kind of lines don't intersect? Parallel lines, right? So if two lines are parallel, then they have no point of intersection. Okay, so finding the points. How did we find the system of equations? What are the methods that we used for solving these systems? Substitution. That's right. All right, let's look at the substitution method since somebody suggested it. Substitution. What do we do in the substitution method?
Solve for either x or y.
We solve one of the equations for x or y, and then we do what?
And then you plug it into
You plug that value for x or y into the other equation. You solve that one and you get a number, and you substitute that back into the other equation, and you get the point of intersection. Okay? So a substitution equation might look something like this. 2x plus y equals 7, and x plus y equals 4. And I like to write systems of equations side by side so we can go back and forth with our substitutions. Yes? For me? All right. Pause this. What Madison just said was perfect. We need to solve one of these equations for one of the variables. Which one do you want to solve for, and for which variable?
X.
x and in the first.
I wouldn't solve for x in the first equation. You definitely want to get y by itself in the first equation if you use the first equation. All right? Because we don't have to divide by anything, we're not going to have fractions. If you solve the first equation for x, you're going to have to eventually divide by 2, and that's going to give you 1/2 y and 7/2 that you have to substitute into the other equation. So let's solve the first equation for y. Or you could solve the second equation for x or y, either way. Let's solve the first equation for y. How would we do that? Subtract 2x from both sides, and that gives us y equals negative 2x plus 7. Why is it plus 7? Because the 7's positive. Now what do I do with that? Take this, substitute it into the other equation in the place of y, because y is equal to 2x minus negative 2x plus 7. So x minus 2x plus 7, there's my substitution, equals 4.
Isn't this the hardest way kind of?
You know, it's negative x plus 7 equals 4. Subtract 7 from both sides, we get negative x equals negative 3, which means x equals positive 3. Are we done? We are not done, because the solution to a system of linear equations is the point of intersection, right? So I can take this x equals 3, substitute it into either one of the original equations. That's why this is called substitution. We're substituting a lot. 3 plus y equals 4 means y equals 1. Okay? So 3, 1 is the solution. Now, how easy is it to go back and check? It's extremely easy. Right? What's 2 times 3 plus 1? That one checks. What's 3 plus 1? That one checks. So you can immediately check all your answers to make sure that they are solutions when it comes to systems of equations. All right? Substitution method is not difficult, particularly if you're given two equations that already, or one equation that already has one of the variables isolated. Okay? What's another method that we looked at? Elimination. This is the method that most people like, because if the equation is set up for elimination, it's extremely easy to do, right? But let's do the same system that we just did. 2x plus y equals 7. X plus y equals 4. To use elimination in this system of equations, our goal is to eliminate. So we need to get opposite variables.
You have to multiply either multiply the top equation. Well, you have to multiply both of your equations.
If we multiply the bottom equation by negative 1, that would eliminate the y's, right? You could multiply the top equation by negative 1 also. Or you could multiply the bottom equation by negative 2 to eliminate the x. But the easiest thing to do is multiply this bottom equation by negative 1, and that's going to do this. All right? Y'all stay with me. I know we just worked this one, but we're using a different method here. Now if you add these two equations together, what do you get? X equals 3. And then we substitute, plug that back into one of our original equations. 3 plus y equals 4. Y equals 1. So again, we get the solution of 3, 1 by using elimination. Okay? That's easy, right? The only time that elimination isn't easy is if we start out with an equation where we're going to have to multiply both equations by something. So if we had 2x minus y equals 7, okay? Well, this one's not going to have to be multiplied by 2, both of them, but let's just work this one. Let's see what's up to 14. We could multiply the top one by 2 to eliminate the y variable, right? Does everybody see that? So if we multiply the top one by 2, what will we have? 4x minus 2y equals 14, right? So now I've got these two equations that I'm working with because I multiplied the top one by 2. Right. And it's okay to do what I just did, just bring it down below, or you could write them both to the side like that. I just don't have room over here. My iPad screen's not wide enough. All right, then we can eliminate, yes? 3x plus 4x, 7x. Positive 2y minus 2y is 0. 7 plus 14 is 21. 28. Thank you. 14 plus 14 is 28. X equals 4. Plug that into one of the original equations. Let's do the second one. 3 times x plus 2y equals 14. What's 3 times 4? Subtract 12 from both sides. 2y equals 2, which means y equals 1. Now, check it. What's 2 times 4 minus 1?
7.
That was good, right? What's 3 times 4 plus 2 times 1? 12 plus 2 is 14. So that is definitely the correct answer. You can know that you know that you know that your solution is correct. It is nice to know. All right, what's the other method that we use to solve systems of equations? Graphing. We used our graphing calculators, right? Now on the test, on the final exam, you can use whatever method you want to use. It's a multiple choice test, and I'm not checking your methods. Okay? So you need to make sure that you are familiar with all these methods, because there's some systems of equations that you'll do in Algebra 2 that you can only use substitution. You have to use substitution. And that's why we don't just teach the easier methods of elimination and graphing. We teach substitution because there's some systems of equations where you must use substitution, okay, to solve them algebraically. All right, so let's have a look at one that we could use graphically. Let's go back to that very first one. Oh, no, let's do the last one. What was the last equation? 2x, Carson, focus, sir. 2x minus y equals 7. And the second one was 3x plus 2y equals 14. Now, why did I write them like this? If we're going to solve by graphing, I have to put them in what form to put them in the calculator? Slope-intercept form, right? So if you subtract 2x from here, that gives us negative y equals negative 2x plus 7. Y equals 2x minus 7. That's right. We can go through and change all the signs and do this. Okay? If you have your graphing calculator, go ahead and open it up and get ready for this. To solve this one, we would subtract 3x from both sides. And that will give us 2y equals negative 3x plus 14. Then we divide everything by 2. And that gives us y equals negative 3 halves x plus 7. All right, so put this into y1, put this into y2. No calculator with you, Gray? And what do you do to find the intersection point? Second trace 5 is the intersection, I believe. Move the cursor close to where they intersect and hit enter, 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 and it'll tell you the solution is 4, 1. Right? Okay. Now this has some